Okay, so this question is taking a ketone and reacting with this molecule here. So this is a very common reagent called MCPBA, and it's a peroxy or per acid. And you can see that because we've got this two oxygens bonded together there. So that's a peroxy group. And the first thing we need to spot here is that a ketone plus a per acid are the quintessential conditions for a Baeyer-Villiger oxidation. Okay, and we don't need to go through the mechanism to know what the product of this reaction is. We're going to get an ester from the ketone via this oxidation. And there's two possibilities though, because we've got an ethyl group here, whereas on the other side we have an isopropyl group. Now that position of the isopropyl group, the one attached to the ketone, is a secondary center, or it's a secondary alkyl group, whereas the ethyl is a primary alkyl group. And in a Baeyer-Villiger oxidation, something that you can just learn by rote, if you like, is that we have an order of preference in terms of which group will migrate to oxygen. So if we get the primary group migrate, we're going to get that group attached to the oxygen of the ester. So that is going to give this product. If we have the secondary, so I'll do this in red, group migrate, we're going to have the ethyl group is still attached to the ketone carbonyl carbon, and then the oxygen has now been inserted in between the carbonyl and the isopropyl group. So this one is the one that will win, and that's what we're really looking for when we ask a question like this in an exam. So if you can remember that, you can spot that as a Baeyer-Villiger and the secondary group migrates in preference to the primary. To answer just what is the product of this reaction, that's all you need to know. If you struggle to remember that, or you struggle to remember what the product is, you might want to look at the mechanism. But I won't go through that in this video, because I think I just wanted to keep it simple and look at the two possible products and show you how you get to the major products of this Baeyer-Villiger oxidation. So in an exam situation, you'd probably, if you gave this as your answer, you might get part marks, maybe half marks, whereas if you get this one here, this is going to be the answer that gives you full marks in an exam. Okay, so hopefully that helps explain what are the key features of this question about the Baeyer-Villiger oxidation of a ketone.